I think this is really cool. I wanted to show you what a motion map looks like in 2 dimensions because it's a little weird. The pass is over there. So, would you agree that the horizontal motion is constant velocity? I just want to show you for this package that flies through the air, okay? So I'll draw this arrow representing v in the x direction, and I'll just make a motion map for an object moving horizontally constant velocity. Again, I think this is really cool. I'm going to show you how to do a motion map in 2 dimensions, which I think is kind of fun, actually. It's just cool. I think it helps you understand what's really happening, okay? In case you're wondering. So in the y direction, this suitcase, so I'll write suitcase falls out of airplane. And it hits the ground. What are we ignoring? I better be clear on that. Ignoring what? Air resistance? Okay. And that's why the velocity doesn't change. So this would be if the velocity did not change at all in the x direction. In the y direction, what's the initial y velocity if the suitcase is not thrown down or up in any way? Okay? I'll try that again. If the suitcase is not thrown down or up in any way, what's the initial y velocity? PV? Marlon looks happy. All right. So the y velocity is 0 in the beginning, and then gradually, I'm just doing a motion map for something falling right here. And I think you'll like how they combine. They combine really neat. Maybe I'll just do those. I think that'll be better. So would you guys agree that my y velocity gets larger and larger? This is my initial y velocity. Actually, my initial y velocity already passed. That's my y velocity at 1 second, maybe 2 seconds, 3 seconds. You can see how the y velocity is getting larger in magnitude. Okay? This part's really cool. Now, if I wanted to find my initial y velocity, this is my initial x velocity. My initial y velocity is 0. So my initial x velocity is my velocity at 0 seconds. You guys with me? Right. So I'm saying my beginning velocity is my x velocity as soon as this object is released. Cool? There's no y velocity yet. But the next second, my object is here. The next second, my object is here. Do you see I'm getting this? I'm lining these up. It is pretty cool. I really like it. It's kind of neat. And then the next second, my object is like over here. I'm really just using your motion maps and combining them in 2 dimensions. That's all I'm doing. And then the next second, well, that was messed up. Whoops. Haha. That's cool sound. You guys, it makes sense, right? Yeah. All right. And I didn't do you can do the same thing for an object that's thrown up and goes up before it comes down, right? You can do the same thing, although it's a little harder. Okay, so now this part's really cool. I'm going to copy my x velocity here and my y velocity there, right? And now I'm going to add those vectors. So my vy and my vx at that moment in time would add to a vector to there. Because look, this is my actual velocity at that moment. Check it out. I could move this x velocity down here, and then their head to tail. These two add to that blue one. So the 2 red vectors add to the blue vector. You all good? And then I can do the same thing. The cool part is the length of that blue vector is actually my speed at that moment. And then when the object is here, like a little farther, again, my y velocity is increased a little bit in magnitude. My x velocity has not changed, right? And my y velocity, I can do the same thing. Has my y velocity gotten longer? I got another question. Do you think it's changed direction at all? Has my actual velocity changed direction? It actually has. You'll probably really see it when I do the next one. So the next one is this, right? My y velocity has gotten even longer. My x velocity is still the same as it always was. And then if I draw my velocity at that moment, can you easily see now how my actual velocity, v, not vy, not vx, but my actual velocity, v, hasn't changed direction? I don't hear you guys.
Yes.
Has my y velocity changed its magnitude? In the beginning, the actual velocity and the initial velocity were identical. Now, at the last moment, my x velocity hasn't changed. It's the same. I drew it a little bit long above by accident. My x velocity is yet a little bit longer, right? Sorry, my y velocity is longer. And then you'll see that we have an even bigger change. We have a change in direction and length for our actual velocity. So, careful, you got to distinguish between x velocity, y velocity, and the actual velocity at a moment in time. So things get a little more complicated in 2 dimensions. All I really want to do is show you how you could do a motion map and how you could actually figure out like the velocity vector at a moment in time. And clearly if you wanted the speed of the object, it's not the speed in the y direction, it's not the speed in the x direction. You actually have to add the vectors. So can you just like, if the x velocity has a length of 5 and the y velocity has a length of 5, could you say the speed is 10? Will that ever work? Yeah, it would never work that way. You actually have to add the x velocity vector or the y velocity vector to find your velocity, and then you have to figure out the length of that vector to get the speed, okay? So it's a bit more complicated because all these velocities have a direction and a magnitude. Go ahead.
So, for the velocity, what if you're not given any sort of like initial or final type of velocity?
Well, you'll always be given enough information to find what you need, but just barely. You know what I mean? Otherwise, the problem won't be solvable, and we won't torture you that way. We could ask you if you have enough information to solve a problem, and you'd have to be given enough information in order to solve what you're looking for. Hee hee. I know I didn't really answer your question. I don't think we'll ever do that to you. Hee hee. Here, I should probably stop this. So that's a motion map in 2 dimensions.